doing it all. Tomorrow you get to go choose your own adventure wherever you want to work tomorrow. If you want to work Hill SAS, we got stuff for you. You want to work 3060, we got stuff for you. If you want to work sine, cosine, tangent, I got stuff for you there. All right, so today's the last upfront review. Just a quick recap of everything that'll be there. Same sheet I've had up there. Same slide I've had up there the last 2 days. I decided to take the cofunctions question off where sine and cosine are equal when their angles add to 90. That's not going to be on there, but everything else, fair game. Law of sines and cosines formula, not on there. You got to memorize that yourself if you want to use it. And that's today's topic. We went through, again, Hills and SAS and the triangles on Thursday before break. Friday before break was SOHCAHTOA, sine, cosine, tangent. And today I'm going to get into elevation, depression, and law of sines and cosines. Okay, and probably talk about what I mean by double triangles too. Anything about the actual makeup? It's going to be pretty tough. It's a full unit, so we just had a 10-day break. So, all right, you ready? Again, I'm going to put all these notes up on Classroom if you don't want to jot anything down. Law of sines. Let's start first. Law of sines. Any triangle. I don't care if it's a right triangle or if it's not a right triangle. Law of sines works. It says the following. A over sine A equals B over sine B. And again, I believe these formulas, yep, I put them on page 55 of your packet. They're right there for you. Just so we know, what do I mean by a and lowercase b? Those are what of the triangle? Side lengths. These are side lengths, remember. And then capital A and capital B are the angles across from them. All right. One thing I got to make a point of, and I don't think I drove home this point well enough when I described law of sines. Everything you plug into law of sines has to come from the same triangle. All the sides and all the angles have to come from the same exact triangle, all right? So all values from the same triangle. You can't say, oh, I'll use these two sides from this triangle and these two angles from this one. No, all four values you plug in have to come from the same triangle. So all values from the same triangle. Everyone, questions there? Anything going? No. Law of cosines. A squared equals B squared plus C squared minus 2BC cosine. Here we go. That doesn't mean side A, because what happens if I have triangle RST, right? That's not side A. What side do I plug in here? Side across from given angle. So I look where my angle, what angle am I talking about in the problem? I look across, and that's what I plug into the left side. What are B and C then? Because it might not be side B and side C. Probably not. The other two sides. And then finally A, that's the given angle. Probably only be one you're working with in the problem. So there's law of sines and law of cosines. All right, let's practice it. And then I got a couple in your group you're going to do. Number 13 from the review. Calculator's ready to go. Okay, this is an example of law of sines and cosines. And hey, take a quick look. This is also what I'm talking about when I say double triangles. All right, on the little sheet slide I have up here with all the topics that'll be on the test. That's what I mean by double triangles. All right, two or more triangles in the diagram. All right, let's tackle this one here. I already put in the 45 and the angle of elevation of 45. Got it? All right, the person at B is 100 feet closer to the base of the building than A is. So we're looking at A. This is 100 right here. B is 100 yards closer than A is. And then the person at B looks up at an angle of elevation of 55. I got that plugged in. And what's the height of the building now? Here we go. What's the height of the building? Whew, all right. So I'm taking a look and I'm like, all right, let's see. Here's the problem though. Everyone see the AB is 100 and it belongs to this triangle right here. Is that a right triangle? No, so I can't use sine, cosine, tangent from SOHCAHTOA there. That's not going to work. There's no way I can find x right now using sine, cosine, and tangent. Right? It's not going to happen. I'm not going to be able to do this problem in just one step, and that's it. So here's what I'm going to need to do. Can you guys find me all the other missing angles for me? I know that's a right angle. Can you guys find all the other missing angles for me? You guys know all the angles add up to 180. Linear pairs are supplementary. There's no way I'm going to find the height of the building in one step. Is 20 up here, this angle? 10?
One of the other ones, is that 25 or 35?
That's a 25. That should be 35, right? Okay. All right, filled in all my values. Now here's my plan. Everyone see the small right triangle here? All right, see that small right triangle? If I went from the 55, what would the x be? Opposite adjacent hypotenuse. Opposite, right? But the problem is I don't know another side to do sine, cosine, or tangent. That's what you guys are going to help me out now. Now I want you to take the smaller triangle here. I know it's not a right triangle, but we're still going to do it. And could you guys find me, I'm just going to put a Y here. Could you find me that side of that triangle? Can you guys find me the hypotenuse of the right triangle using this green one I've highlighted? Because if you do, then I could do, oh, I got opposite, and now I have hypotenuse. I can use either sine, cosine, or tangent. But can you help me right now, using this triangle I've highlighted in green, find that missing side? I can use law of sines. And one of you guys are going to figure it out here for me. So I'm going to find dB now. We're going to find dB. Because if you find dB, I can get to the height of the building. Only use values from the same triangle. All right, give me a side from that triangle you want to plug in. Give me a side you want to plug in. Ah, man, just deleted that out. Let's try that again. 2, 4, here we go. 12. Give me a side from that triangle I can use. 100 over, what am I going to put it over now? 100 over, if I'm using law of sines. 13, 100 over.
10.
Sine 10. Everyone's good? Where I'm getting this from? All right, now the missing side, y, over, what's the angle across? In the same triangle, remember? 6. Sine of 45. There you go. Does everyone see all 4 values come from my green triangle? And now this will help me solve for the hypotenuse. And when I have the hypotenuse, boom, I can find the height of the building. Here we go. Let's cross them up. Sine of 10 times y equals 100 times the sine of 45. And quick question for one more person. How are you going to get the y by itself? What do you got to do on both sides to get y by itself? 11?
Divide.
By?
Sine.
Good job. What are you not going to do to this answer? Because this won't be my final answer. We're not rounding this. We are not rounding this. It's going to be correct.
Yeah.
Are we getting like 407 and change? Thank you. All right, now, step 2. Now we can find the height of the building. Because now I have opposite and hypotenuse. What can I now use if I'm looking for the opposite side and I know the value of the hypotenuse? I can use which one? Sine, cosine, or tangent? 16? If I have the opposite and the hypotenuse, what can I use?
The opposite and the hypotenuse.
In SOHCAHTOA, what has opposite and hypotenuse with it?
Sine.
Sine. Or, I don't know if anybody's thinking down this, could I use law of sines again? On this right triangle, could I use law of sines again? Yeah, I could say x over sine of 55 equals 407 over sine of 90. I can use both. All right, I can use both. So I'll do sine of 55 equals opposite side x over hypotenuse, that 407 and change we just found. Or again, you want to use law of sines, use law of sines. You could still do law of sines. And then cross multiply for me. And what's it asking me here? Nearest hundredth. So 2 numbers after the decimal place. Better be right, George. 333.54? No? Looking good, Luke?
I got 333.56.
5.6?
Oh yeah, 5.6. Just put the full-
Okay, units on this? 100 feet? Yep, so feet. Make sure we put units on. Anybody want to chime in with anything here? This is what we're looking at. Some of the problems at the end of the test, something like this. Okay, where you're can't answer in one step. Zach, go ahead.
Couldn't this have been done in a 45, 45, 90 as well? If you did X.
Where's your, okay, 45, 45, 90. The 100's not a full size. I couldn't use the 100.
Yeah, because
Go ahead, talk to me.
CA would be X minus 100.
Okay.
And then that would equal. I'm trying to think. There is a way. I'm not sure. I was just wondering.
Okay, let's, see how I solved for this right here?
Yeah.
Let's say you solve for this right here using law of sines. Now that's the hypotenuse in a 45, 45, 90. So you could divided that by radical 2 and got the answer, yes. That is a way to use your 45, 45, 90 rules, but I do need a side from the 45, 45, 90 to work with. And that side would have been its hypotenuse dA. Okay? Yep. Any other questions, comments? Go to classroom for me. One of the files should be law of sines, cosines practice. So you go to your unit test review material. One of the files should be law of sines, cosines practice. And can you go to number 6? We're going to work with number 6. I know it says solve the triangle, but I don't have time for that. We don't have time to solve. I'm going to pick an angle, and we're going to find the angle on number 6. So you got sides 20, 17, and 30. I'm going to challenge you right now. I want to find right away, find the biggest angle. Find the biggest angle right away. Do you know where the biggest angle is first? So I don't have to find all 3 and circle the biggest one. That takes too much time. How can I figure out what the biggest angle is right away? Where's the biggest angle going to be across from cell?
The biggest side.
Biggest side, so I'm looking for angle what here? Angle A. Yep, we're going to solve for angle A right now. Everyone all right? Why? We know that's the biggest angle. It's across from the biggest side. So let's solve for angle A. Ooh, which formula do I need here? What's going to do it for me? Sines or cosines? Sines or cosines? Which one's going to do it? Well, look here, look. Let's just say you thought it was sines. You're going to be like, oh, all right, 30 over sine A equals 20 over, you're going to have another variable. And that's no, does everyone see? I can't use sines. I don't have enough info. It's not going to happen. Not going to happen. So I got to use cosines. Here we go. A squared equals B squared minus C plus C squared minus 2BC cosine A. Again, not wasting your time. I know it's going to be on there. All right, what side do I plug in for A now? Side across from the angle. If we're working with angle A, what's across from it? Here we go. 4, what's across from A? 4 here, no? Going? Okay, let's try again. How about 18? 30 squared equals, what's my B and C values then? 8?
20 and 17.
20 squared plus 17 squared minus same B and C values. 2 times 20 times 17 cosine A. In this case, we'll keep it A because it's angle A. I know it's been a long time since we've done these. Your goal, get cosine A by itself. Get cosine A by itself. So let's figure out all the squaring right now. Grab your calculator. 30 squared, 900. 20 squared, 400. Can I get a little help? 17 squared, 320, no, 324 or 289. 289 minus, oh boy. Why am I'm not even going to try. Well, maybe, hold on, can I do this? That's going to give me 34. That'd be 340 and 340, 680?
Yeah.
Machine. Reminder, can I combine all 3? No, I cannot combine all 3 of these. I can combine the first 2, but I cannot combine it with the minus 680. Cannot. There's a variable with it. Cannot. The only thing I can do is this. 400 plus 289 is 689. Do not try to combine all 3. Next move. Can't combine the 689 and the 680, but I need cosine A by itself. Need to get that by itself. What do I move over and how do I move it over? Dig deep, dig deep. 7. What do I need to move over? There you go. There we go. Minus 689. Oh, 211. Make sure negative 680 cosine A. Still got to get cosine A by itself. Still need cosine A by itself. What do I still need to do on both sides? You guys are doing a nice job. Keep it up. Keep it up. 5. Divide by. I want to keep it there. I don't want to touch it. Negative 680 on both sides. That'll give you a decimal. Cosine A. You can turn it back into a fraction or leave it as a decimal. It's up to you. So 211 divided by negative 680. Why do I even bother? It's better. I'm not even joking here. Math fraction. It doesn't even turn into a, can't even reduce that. Or you can write that full decimal out there, that negative 0.31029. All right, last step. What is angle A and how do I find it using your calculator now? I got cosine A is equal to that fraction. How do I figure out what angle A is equal to now? What's that last step, Romeo? Inverse cosine. Yeah! Inverse cosine. Use your fraction. Second cosine. Remember, you don't have to retype it. You can just, most of you guys can just copy paste. And what do you got for angle A? Second cosine. Make sure cosine, this is not law of sines, law of cosines. So second cosine. What's it asking? Nearest degree, probably. Round your answers to the nearest tenth. Sorry. Nearest tenth, 108.1 degrees. Now, if I was to go back and find a second angle, I could do law of cosines again to find either angle C or B, or can I do law of sines now to find one of the other two angles? Yeah, I could say 30 now over sine 108.1 equals, pick one, 17 over sine C. And now I do second sine at the end. Or you can do law of cosines all over again and find a second angle. Questions? Time for one in your group right now. How would you go about number 2? Find angle A. Okay, how are you going to go about number 2? Find angle A. Same sheet, same sheet. So discuss it in your group. Jax, you can move over with those in the back, that group in the back. Go ahead, find angle A. Figure out first what formula is going to help you because it's not a right triangle. Number 2, what formula can I use here? All right, just let me go through it, making sure we got this down. So law of sines, first of all, it got to be law of sines. 28 over sine 62 equals 25 over sine A. We'll cross multiply and get 25 times the sine of 62 equals 28 times the sine of A. We'll then divide both sides by 28 to get sine A by itself. Sine A is now equal to a decimal, or maybe some of you might have left it as a fraction. Is this right? 0.788 3460665. And then now I do second sine. Anytime you're finding an angle, use the inverse. Use my inverse if I'm finding an angle. And then round to the nearest tenth. What was it, 53 degrees? 50?
2. Point up.
0.0. 52 degrees. Good. Any issues? Last one in your group. Go back to your packet. And number 10. Number 10. Now you got to fill in everything now. Fill in everything. From your packet, Luke. 10 from your packet. Yeah. 10 from your review packet. The question's in the back of your packet, number 10. Yes, 125 is the length of AB. 125 is the length of AB, everybody. 125 feet closer. I am not going to do this one up front with everyone. You guys could just open up the answer key on Classroom and see if you're right or wrong. All right, because you have the answers to these. So when you think you're done, you and your group think you're done, check your answer up on Classroom. Answer key's up there. And then you can go wherever you want to work on after that. All right, so if you're having trouble, call me over. If not, just keep working through everything else you need, anything you need work on. Textbook, packet, classroom stuff.